Welcome to our YouTube channel, where knowledge meets creativity and inspiration sparks innovation. We are excited to have you join us on this journey of exploration, learning, and discovery. Our Earth is in danger. To mention a few of our less than beneficial legacies, humans are both the cause and the victim of deforestation, ocean acidification, and rising temperatures. Although the facts are complicated, it is difficult to argue with the trends. However, the subject of global peril raises a lot of eyebrows these days, making it difficult for readers to avoid taking a defensive stance. Perhaps it's because we're constantly confronted with the worst scenarios and aren't often given the chance to savor the answers. Therefore, perhaps the notion that technology can contribute to making our world a more comfortable and sustainable place for humans to continue toiling away is less contentious. A definitive list of the 10 technologies that will ensure the survival of our planet is probably a lost endeavor, despite the article's high title. You will undoubtedly disagree with some items on this list. Fine, I'd love to hear from you in the comments section, which is where it belongs. 10. Solar glass. What if every window in a tall building could produce energy? That's the promise of solar glass, a cutting-edge innovation that's gaining a lot of attention in the design and sustainability worlds. Solar glass is a transparent window material that, true to its name, also absorbs solar energy and transforms it into electricity. Efficiency has been a major barrier. The efficiency with which light is converted into energy must be sacrificed in order to retain transparency in high-performance solar cells, which can achieve 25% efficiency or more. However, a team from the University of Michigan is working on a solar glass product that will let 50% of light to get through while still operating at 15% efficiency. 9. Graphene. Graphene is certainly a wonder material, and one that was, until recently, only a theory. Stronger than steel, thinner than paper, and more conductive than copper. At the University of Manchester, graphene, an incredibly thin sheet of graphite, was first identified in 2004. It is currently the topic of extensive study and conjecture, with many anticipating that it will advance our species' cultural and technical growth after bronze, iron, steel, and silicon. Graphene, which is only 1 atom thick, is highly conductive, transparent, and flexible, making it appropriate for a wide variety of applications in planet-healing technology. These include, to name a few, solar applications, water filtration, and superconductors that can transmit energy over extremely long distances with little loss. 8. Plastic made from plants. Single-use plastics must be eliminated. There are already plans in place across the United States to outlaw or drastically restrict their use. In Leh, where I currently reside, plastic straws are only provided upon request, and grocery stores no longer stock single-use plastic bags. However, the issue is ingrained in our consumption-based economy and has a long history. The amount of plastic waste that is readily apparent on a daily basis where I live is horrifying. One acceptable approach is the use of biodegradable plant-based plastics, which might, in theory, replace many of the plastic items currently in use. Since 2014, the Indonesian company Avani Eco has started producing bioplastic from cassava. This industry should experience rapid growth in the next years, much like fake meat and solar glass. But take note, not all bioplastics decompose, and the effectiveness of some production methods is in question. 7. Man-made flesh? Greetings, carnivorous, I've got both good and bad news. Initial negatives: production of meat is terrible for the environment. In a warning to humanity published in 2017, more than 15,000 scientists from around the world recommended, among other things, dramatically reducing our per-person consumption of meat. Land utilization is a concern. One of the main contributors to deforestation in Central and South America, where 100 grams of beef require 164 square meters of grazing pasture, is the production of beef, which results in a record-breaking release of carbon into the sky. According to the Food and Agriculture Organization, livestock is responsible for 14.5% of anthropogenic greenhouse gas emissions. Animals consume enormous amounts of fresh water, and industrial livestock farms' polluted runoff contaminates nearby waterways. 6. Battery? Many green technologies are constrained by the availability of power. For instance, wind and solar energy are capable of producing enormous amounts of electricity, but their uptake has been hindered by a serious drawback. It isn't always windy or bright. Similar to electric cars, which are making great progress, fossil fuels will continue to dominate until their range and charging durations shorten. Current battery technology will not suffice. It's too pricey, for one thing. According to the Clean Air Task Force, California would need to invest $360 billion on energy storage devices in order to reach its lofty ambitions of running entirely on renewable energy. A business by the name of Form Energy is creating what are known as aqueous sulfur flow batteries, which are expected to cost between $1 and $10 per kilowatt hour, as opposed to lithium's $200 price. 5. Environmental sensors. We need to measure the world if we want to cure it. Distributed sensors are one of the underappreciated technologies that make it possible, and the continuous growth of the network sensor environment will be one of the enabling technologies for almost all sustainability initiatives. Need an illustration? Taller smokestacks on the East Coast in the 1980s contributed to a decrease in regional air pollution. The issue was that smokestacks were linked to more acid rain, which was causing extensive deforestation. In what way was the connection made? First-generation networked pollution sensors. Of course, technology has since improved. Smaller than a cent in size, networked sensors are already in use to detect acidification, identify pollutants, monitor air and water quality, and collect real-time data on a variety of other phenomena that are essential to our social and economic well-being. For smart grids, it is alarming to see how our power infrastructure, generally referred to as the grid, still operates today. Power generation is still mostly centralized, disseminated laterally, and delivered to end customers. These grids' sensitivity to changes in consumption and output is the problem. They need an excessive amount of energy to function consistently. They are easily attacked and frequently use energy sources that release pollution. In testbeds, both domestically and abroad, smart grids are already being implemented. Instead of focusing on a single technology, the idea is to use a variety of energy, distribution, networking, automation, and sensing technologies to create a new grid for the 21st century. Local energy production at the household level will be possible thanks to smart grids, and this energy can then be supplied back into the grid upstream. Improved sensor technology and more precise forecasting models will regulate energy production to prevent overproduction, while improved batteries will permit the storage of energy from renewable sources. Even outside of the light socket, the idea is applicable. The grid may begin to automatically alert appliances to turn off, so they may save energy as they become smarter. 3. Carbon capture. Our globe is warming due to an excessive amount of carbon dioxide in the atmosphere. What if we could catch it and imprison it? This is the foundation of carbon capture and storage, CCS, a new class of technologies that will be crucial to the future health of our planet. The CCS Association states that one of three methods, pre-combustion capture, post-combustion capture, or oxy-fuel combustion, allows carbon dioxide to be separated from gases produced in electricity production and industrial operations. Pipelines are used to transfer the carbon, which is then deposited in deep underground rock formations. 2. Nuclear fusion. Hydrogen fusion, which produces helium, powers our sun. Scientists have been attempting to harness the same process for the creation of long-lasting terrestrial power for decades. Because it provides an energy source with zero carbon emissions, the project is incredibly compelling from an ecological perspective. Fusion does not lead to the creation of radioactive nuclear waste with a lengthy half-life, unlike nuclear fission, the process that drives today's nuclear power plants. Heat is a concern. When two particles combine, the process must occur at millions of degrees Celsius in order to produce net positive energy, which implies that the container you're using to combine the particles will, well, melt. The solution, which researchers believe can be accomplished using strong magnets, is to suspend the reaction in a floating plasma so that the intense heat doesn't contact the chamber. 1. Computerized learning. Artificial intelligence may end us all in a variety of sci-fi scenarios: nuclear destruction, deliberate extinction of species, rise of the robots, etc., but it also may be our best hope for solving our current problems. One initiative to use artificial intelligence for the benefit of the Earth is Microsoft's AI for Earth initiative. In one of 4 areas, biodiversity, climate, water, and agriculture, the initiative has awarded more than 200 research grants to teams using AI technologies. Subscribe to our channel for a dose of knowledge, creativity, and inspiration delivered right to your screen. Join our community and embark on a journey of discovery together. Don't miss out on the captivating content we have in store for you. Hit that subscribe button now, and let's explore the wonders of the world.